Okay, in section 2.4 we will consider linear equations in two variables and also linear functions. For a linear equation, here a, b, c are real numbers. A and b cannot be both zeros. For a linear equation in the variables x and y would be an equation that has the form ax plus by equals c. Here is an example. The graph that we see here is the graph of the linear equation 2x plus y equal minus 2. طبعا with that's why we call them linear equations. If you graph the equation you will get a straight line. طبعا a straight line can be graphed by plotting 2 points. 2 points is sufficient to graph a line. Just take 2 points that satisfy the equation. If you draw a line between them, that will represent that linear equation. Now there are special cases for the line. One is the horizontal line. In a horizontal line, all the y values are fixed. The y does not change. But the equation in this case will have the form y equal k, where k is a constant. The picture to the left, the graph to the left, is a graph of a line that has the equation y equal 2. Here, طبعا this is the equation that represents the line. In this line, the y value stays fixed at 2. طبعا the x value varies, but for any x, the y value will equal to 2. But here is an example of a horizontal line. Now a vertical line has the equation that have the form x equal k, where k is a constant. And here is a picture of a vertical line. The equation for this line is x equal 2. Here the x values are constant, stay the same. For all the points on this line, the x value is equal to 2. The slope for a line is if you have a point, if you have 2 points x1 y1 and x2 y2, the slope is defined to be delta y divided by delta x. That means the change in y divided by the change in x. So you can calculate it by taking y2 minus y1, that's the change in y, divided by x2 minus x1, which is the change in x. طبعا this quantity can be calculated for any line except for vertical lines, because طبعا the vertical line, the x value is fixed. If you try to calculate the slope in this case, you will have an undefined slope. For a horizontal line, since the y values stay fixed, for a horizontal line the slope will be 0. So these are the two special cases. The horizontal line will have slope equal 0. The vertical line, the slope is undefined. Here is an example how to calculate the slope of the line passing through 2 points. The first point is minus 4 and 5. The second point is 6 and 3. This is just applying the formula. The slope will be the change in y, 3 minus 5, divided by the change in x, which is 6 minus 4. طبعا the numerator 3 minus 5 is just minus 2. 6 minus 4 is just 6 plus 4, which is 10. And you can simplify this expression by طبعا dividing by 2. The slope now is equal to minus 1 over 5. The slope here is negative, which means the line is slanted from left to right. The negative slope will indicate that when x increases, y will decrease, as we will see in many examples that we will look at in the next few slides. Of course, we started with the one form of the line, which is of a linear equation in two variables. There is another form to write the equation of the line, and this is called the slope-intercept form of a line. طبعا from the name here, that means you need to know the slope and you need to know the y-intercept. For here, for given a line with slope equal to m and y-intercept equals 0, b, that means the line intersects the y-axis in point 0b. For the intercept form you can write the equation of the line in this form, y equal mx plus b. For any time you write the equation of a line in this form, the coefficient of x will give you the slope, and the constant here will give you the y-intercept. طبعا يعني only if you write it in this form that you can find the slope just by taking the coefficient of x. Now you can define a function here. When you write the equation of the line in the slope-intercept form, you can see that y will be a function in x. So you can replace y by f of x, يعني just to indicate that y depends on x. So you can just write f of x equal mx plus b. So in this case, of course, f is a function of x. طبعا m doesn't equal 0. If m equals 0, you have a constant function. But if m does not equal 0, you have a linear function. The graph will be a slanted line, and it will have a slope to it. If m is equal to 0, then you have the constant function f of x equal b. Here it will be a horizontal line. You can think of a horizontal line as a function f of x equal a constant. Here طبعا the slope will equal to 0. The question is, what if you have a linear equation in two variables? You know it's a line. So how do you write the function? How do you write y as a function of x? How do you write it in the slope intercept form? And that, of course, will just take some manipulation. You can manipulate the linear equation to write it as y equal ax plus b, or mx plus b, and you write it in the slope intercept form. So starting with this equation, linear equation, 2x plus 9y equal 18. The first step is to isolate the y term. If I subtract 2x from both sides, you have 9y equal minus 2x plus 18. Divide both sides by 9. You have y equal minus 2 over 9 times x plus 2. So now you can replace y by f of x, and here is your function. F of x equal minus 2 over 9 times x plus 2. This line, the graph of this function will be the line that we started with, which is 2x plus 9y equals 18. طبعا here in this form, the coefficient of x will give you the slope. For the slope is equal to minus 2 over 9. The y-intercept will be 0, 2. Then this 2 here is b. For the y-intercept is 0 and 2. For a function, if you write, this is true, you can do this for any function, not just the line. If f is a function that's defined on the interval that starts with x1, this is a closed interval from x1 to x2, we define the average rate of change. طبعا the average rate of change for the function in the interval from x1 to x2. This is the slope of the line secant. This is a line passing through the 2 points, x1, f of x1, and x2 and f of x2. طبعا that would be, using the definition of the slope, would be f of x2 minus f of x1 divided by x2 minus x1. So here, remember now, f can be any function. The function is defined on the interval, so the left end points of the interval will define a point on the graph of the function. This is x1 and f of x2. The second point, the right hand point of the interval, x2, will define a second point, which is x2 and f of x2. Now the average rate of f in that interval will be just the slope of the line passing through these 2 points. طبعا then the calculation is really easy. You look at the change in y, f of x2 minus f of x1 divided by the change in x, which is x2 minus x1, which is, by the way, is the same as the length of that interval where the function is defined. We will look at an application in the next slide. Here is an application where we calculate the average rate of change for the function. We want to calculate for this function. First of all, this function represents temperatures. For the independent variable, the horizontal axis represent the time, expressed in months. So you have the range here, or the available values in the x-axis are the different months, starting from 1, 2, 3, up to the 12th month. The y-coordinate, the vertical axis, represent temperature. For each one of these points, the x-coordinate will give you the month, and the y-coordinate will give you the average temperature during that month. So you have a point for each month. Each point have two coordinates. The x-coordinate represent the horizontal value, or the time of the year, the month, and the y-axis will give you the temperature during that month. Here are 2 points in particular. We are interested in the average rate of change for the function in this interval from 8 to 10, from the 8th month, August, to the 10th month, which is October. We want to look at the 2 points that the endpoints define. When x is equal to 8, for the 8th month, y is 81. That tells me the average temperature during August, the 8th month, is 81. The second point for the interval, the right-hand point, is 10. That's the 10th month, or October. The point here would show me during the 10th month, the average temperature is 71. Now, the average temperature in that period, from the 8th month to the 10th month, is simply the average rate of change for the function that represent the temperatures. To do this, of course, you just take the slope of we have 2 points. The first point is 8 and 81. The second point is 10 and 71. The slope of the line passing through these 2 points will give you the average change of temperatures during that period. Okay, the slope now is f of x2 minus f of x1 divided by x2 minus x1. That would be 71 minus 81 divided by 10 minus 8. This is minus 10 divided by 2. This is equal to minus 5. As the slope, this is a negative slope. As x increases, y decreases. As an average rate of change for this function represent temperature, what minus 5 tells me that during that period, from the 8th month to the 10th month, the temperatures are dropping by an average of 5 degrees. Every month the temperature will drop by 5 degrees. That's what the slope is. The slope is an average rate of change. The function itself may have different values in that interval, but the slope for the line passing through these 2 points will give you the average change, which for our function is minus 5. The function represents temperatures, but you can explain this result by saying that the average temperature will drop by 5 degrees from the 8th month to the 10th month. Okay, next we would like to see how to solve equations and inequalities graphically. We solved equations before using algebra. We did also solve inequalities. Now we want to see what that means as far as the graphs. For example, if you have an equation that may represent 2 different lines, in the equation, the one side equal to the other side would just give you the point of intersection of those two lines. Yani for example, if you look at this equation, 2x plus 2 equals minus x plus 5, you think of the left hand side as the first function, f of x equal 2x plus 2. The right hand side is the other function, minus x plus 5. By setting the y value to be equal and solving for x, that will give you the x coordinate for the intersection. And this is what we will see on the graph. The blue line here is the graph for the function f of x equal 2x plus 2, which is the left hand side. The right line is the graph for the function g of x equal minus x plus 5. طبعا if you have a graph, especially if you have an accurate graph, you can find the points of intersection. It looks like the points of intersection has coordinates 1 and 4. Okay, that same point you can find solving these two equations algebraically. But one thing is to verify this point 1 and 4, we get it from the graph. How do we verify that it is the point of intersection? Well, by showing that the point is on both lines. Both lines will pass through this point. So if you go to the first line, the red line, g of x equal minus x plus 5, that means if I substitute x equal 1, y must equal to 4. But if we substitute x equal 1, you have minus 1 plus 5, which is equal to 4. Then the line g of x equal minus x plus 5 passes through the point 1, 4. You can do the same for f of x, the blue line. The equation here is 2x plus 2. If you substitute x equal 1, then you get 2 plus 2, which is 4. Then the second line also passes through the point 1, 4, and that would verify that it is the point of intersection. Now, before we did solve equations, to do this algebraically, what it amounts to is set the y value to be equal, set f of x equal g of x, and solve for x. That gives you the equation in part A, 2x plus 2, that's f of x, equal minus x plus 5, which is g of x. And if you try to solve this equation, for example, if you add x to both sides and subtract 2, you will have 3x equal 3, or x is equal to 1. You can get the y value by using either equations of the line. You can get the y value. Now, what about inequalities, linear inequalities? We have seen how to solve linear inequality, and solutions for inequalities just gives you the values that satisfy the inequality. But if you think of in terms of lines and graphs, these are the same functions, f of x and g of x. Each one of these functions is a line, which is in the graph. What does this is now part B. The inequality 2x plus 2 is less than minus x plus 5. We know how to solve this algebraically. You do the same thing, add x to both sides and subtract 2. You will have 3x is less than 3, or x is less than 1. That's the solution. But what does it mean for the graph? Well, the left hand side of the inequality is just the f value, or the y value for f of x. The right hand side is the y value for g of x, the second line. Here the solution, the graphical solution, is you want to find the points where the y value for the blue line are under the y values for the red line. And it's very clear that this is true for all x less than 1 to the left of 1, the y value for the blue line will be less than the y value for the red line. What about this third inequality? You can also argue similarly. The left hand side is just represent f of x, the blue line. The right hand side is just g of x, which is the red line. The solution for this inequality are those points on the graph where the y value for f of x with the blue line are larger than or equal to the y value for g of x, the red line. And that it should be very clear that this starts all the points on the line and also all the points above the red line satisfy this condition, that 2x plus 2, which is that's g of x, is greater than or equal to minus x plus 5, which is f of x, the left hand side, will be greater than g of x. Here graphically this is just the points where the y values or the function values, here 2x plus 2 is just f of x, so you're looking for the interval where the y values for f of x is larger than g of x, and that's exactly the interval from 1 to infinity. If either solving equations or inequalities algebraically, the solution set, you can see what that means when you look at the graph of functions. We did this now for a line, both functions are lines, but you can always interpret solutions. Anytime you have a solution set, you can interpret it using the graph. Okay, this is now both linear equations and inequalities, solving them graphically. The next thing, 2.5, we want to look at applications of linear equations and modeling. We did this before. Modeling means you use an equation to represent a real life quantity. In particular, we want to look at applications now of linear equations. The point slope formula for the line is given by y minus y1 is equal to m times x minus x1. This is yet another form for the equation. In fact, this formula will enable you to write the equation of a line. If you know one point on the line and you know the slope of the line, you can use this formula to write the equation of the line. This is called the point slope formula. It is y minus y1 equal m times x minus x1. Here x1 and y1 are the coordinates of the known point. That's the point we know. M is the slope of the line, and x and y are the variables. So once you substitute the values for x1 and y1 and for m, the slope, then the result will be the equation of the line. So here is an example of how to do this. We want to use the point slope formula to find the equation of the line, passing through the point 2 and 1 and having the slope equal to 4. For the slope is 4, the known point is 2, 1. For here in the formula, x1 is 2 and y1 is equal to 1. So it's a matter of substituting in the point slope formula. Here is the point slope formula, y minus y1 equal m times x minus x1. M is the slope, x1 and y1 is the known point. So here now we want to substitute 1 for y1, substitute 4 for the slope, and substitute 2 for x1. The remaining steps is just to simplify this equation. You can start by multiplying 4 by the bracket, x minus 2. We get, on the left hand side is y minus 1 equal 4x minus 8, 4 times 2. Next, add 1 to both sides. You have y equal 4x minus 7. This is the equation of the line that satisfies these two conditions. It passes through the point 2, 1, and it has a slope equal to 4. It is not difficult to verify that this equation does work. It is clear from the equation that the slope is just the coefficient of x, so the slope is equal to 4. Does this line pass through the point 2, 1? Well, we need to substitute 2 for x and see if we get 1 for y. طبعا if x in this equation y equal 4x minus 7, if we substitute 2 for x, we get 2 times 4, which is 8. 8 minus 7 is 1, so we get 1. Okay, then the coordinates of this point satisfy the equation, which means the point is on the graph of this equation, and therefore the line passes through the point 2 and 1. The graph, by the way, is, we have the graph of this line to the right. You can see that it passes through the point 2, 1, and the slope is 4. The slope is positive, the slope is 4. That means when x increase by 1 unit, the y value will increase by 4 units. Here are now some properties. We can use the slope, and there's two properties that we can use by looking at the slope of a line, and that will give us now a relationship between the slopes of parallel lines and perpendicular lines. طبعا parallel lines, what that means, if you draw any two lines, if you draw them on the plane, then they either intersect in one point or they never intersect, they never meet. The distance between them stays fixed, and that's what we mean by parallel, that the two lines never intersect, they never meet. طبعا perpendicular means each line is perpendicular to the other line, which means that they make an angle of 90 degrees. So we will see how to use the slope to check for parallel lines and for perpendicular lines. So let M1 and M2 represent the slopes of two non-trivial parallel lines. Then here, whenever the two lines are parallel, what will happen in the slopes will be equal. M1 will equal M2. The converse is also true. If you have two lines with the slope equal, if two lines have the same slope, then they will be parallel. The other property being perpendicular, they make an angle of 90 degree angle. In this case, how do we compare the slopes? Again, M1 and M2 represent the slopes of two perpendicular lines. Then M1 is equal to minus 1 over M2. This relation can be written if you multiply both sides by M2. That means the product of the two lines, the two slopes, is equal to minus 1. Which also means if you know the slope, if you know two lines are perpendicular and you know the slope of one of them, you should be able to find the slope of the other one using this equation. So here, just to summarize, if you have two lines, if the two slopes are equal, then the two lines will be parallel. If the product of the two slopes is equal to minus 1, then the two lines will be perpendicular to each other. Here's an example. Suppose you have a line that have slope equal to minus 1/2. Now any line that's parallel to this line will have the same slope, will have slope equal to minus 1 over 5. What about the slope of any line that's perpendicular to this line? It will have slope equal to 5. This is the slope of the line we started with, minus 1 over 5. Any perpendicular line, the slope will be, take the reciprocal and change the sign, but you will get 5. You can verify this. If you multiply 5 times minus 1 over 5, the result will be minus 1. So the two lines are perpendicular. Next, we would like to use linear function in an application. Here we have a family plan for a cell phone, has a monthly base price of $99 plus $12.99 for each additional family member added beyond the primary account holder. If we want to write a linear function to model the monthly cost, we can call it C, capital C of X. The cost will be in dollar. for X additional family members. Yani we know the cost depends on how many family members you add to the plan. This is X, this is our variable X. Then the cost will depend on X, which is the number of additional family members. Then the cost will be a function in X. It depends on X, which is the number of family members. After we do this, in part B, we want to evaluate C of 4. Yani we want to find the cost of the plan if you have 4 additional family members. And now we expect that our model will be linear. For the cost as a function of X will be M times X plus B. طبعا B here is your fixed cost. And if X is 0, if you have no additional members, the cost of the plan will be 99. For B is equal to 99. Now M times X, M here must be equal to 12.99. Then for each additional family member, you pay 12.99. If you multiply 12.99 by X, it will tell you how much money, extra money, you have to pay. يعني you have the base price, which is 99, plus for each additional family member you are paying 12.99. يعني multiply 12.99 by X will tell you the extra cost, and طبعا add it to the minimum, which is 99. This plan, يعني this function is a model for the total cost for that plan. And by the way, طبعا if you set X equals 0, يعني if you have no additional family members, then طبعا this will cancel. يعني 12.99 times 0 is 0, and you pay the minimum charge, which is 99. If you have any additional family member, just substitute that for X, and that will tell you how much the cost is. Now in part B, we were asked to evaluate C of 4 and interpret the meaning of this problem. Well, C of 4 tells you the cost of the plan if you have 4 additional family members. طبعا to evaluate C of 4, then in the equation that represents the cost, substitute 4 for X. So you have 12.99 times 4 plus 99. It should give you $150.96. Yani this is now the total cost for the plan if you add 4 additional family members. Next, we would like to we'll cover chapter section 2.8, which is the last section. We will consider the algebra of functions and function compositions. All this is operations that you can perform on functions. طبعا we know addition and subtraction and multiplication for numbers. How do you apply it to functions? Well, this is exactly what we want to do. يعني starting with 2 functions f and g, you can add them together. That will give you a new function. We call it f plus g. You can subtract the 2 functions f minus g. You can multiply them, or you can divide them. يعني multiplication here is f times g. This dot means the product. And the last thing is طبعا division, which is f over g. Each of these operations will give you a new function. So we will see how to define these operations for functions. F plus g of x, طبعا this is a new function, f plus g. How do you evaluate it at any x? Just take f of x plus g of x. So طبعا if I have the formula that defines f and g, you just substitute the formulas for f plus, and then substitute the formula for g. Subtraction is defined similarly. The new function f minus g of x is just equal to f of x minus g of x. The product f times g of x is f of x times g of x. Finally, the division f over g of x is just f of x divided by g of x. And here you have to be careful, of course, since this is a rational expression. You want to exclude the values that will give you 0 in the denominator. we call these restricted values. يعني if you form the quotient f over g, you need to exclude the values that will make g of x equal to 0. Okay, the composition now is a different operation. The composition of f and g, and this is how we write it. F circle g, this is different than dot. This is not the product. This is a small circle that denotes the composition of f and g. For f circle g, or the composition of f and g evaluated at x, is just f of g of x. So that means you apply, the first function you apply is g. طبعا whatever you get for g of x, now you can apply f. So you have to do it in that order. When you say the composition of f and g, this is f circle g, you must apply g first. F of g of x. طبعا يعني if you want the composition of g and f, that will change the order, but you will not get the same function. But make sure that you, when you are forming the composition, f circle g of x, apply g first and then apply function f. Now what about the domain for the composition? The domain of f circle g, or the composition of f and g, you take the set of all real numbers x in the domain of g, the first function you apply, such that g of x will be in the domain of f. You want to do this so that f of g of x will be defined. فيعني start with the domain of g, which is the first function that you will apply. Pick the values in the domain, provided that g of x, and if I apply g, the result will be something in the domain of f, so that f of g of x will be defined. Here are examples for some of the operations. Here f of x is equal to x minus 3, g of x is equal to x squared minus 7x. Let's do the sum. F plus g of x is defined to be f of x plus g of x. So replace f of x by the formula, which is x minus 3, plus g of x, replace it by x squared minus 7x, and you need to simplify. طبعا you know that you will get a polynomial. Write the highest power first, and write x squared. Then you have x and minus 7x, this is just minus 6x, and then you also have minus 3. For this second degree polynomial, x squared minus 6x minus 3 is just f plus g. Yani the sum of f and g will give you this polynomial, x squared minus 6x minus 3. Subtraction is done similarly. There is no example here for the subtraction, but it's done the same way. And طبعا يعني you do have to simplify, because you want to give the sum or the the difference, you want to write it in a simple form. Let's do the one for division. G over f of x, by definition this is g of x divided by f of x. Now replace g of x by its definition in the formula, x squared minus 7x divided by f of x, which is just x minus 3. For this is the definition of g over f. But طبعا you don't want the denominator to equal 0, so you have to exclude x equal 3. فيعني this expression here is defined for all values except x equal 3. يعني x cannot equal 3. Now for the composition, let's look at an example for the composition. The first function f of x is equal to 1 over x plus 12. The second function g of x is equal to x squared minus 7x. Let's do f circle g of x, which is just f of g of x. Now to find the form, or the closed form for the composition, you are applying f of g of x, and g is applied first. But this is exactly, when you look at it, this is the same thing as f of x, and if you start with f of x, replace x by g of x, you get f of g of x. So it will give you the composition. For f of g of x, start with the outside function, which is f, replace x by g of x, and that will give you f of g of x. طبعا the definition for f of x is 1 over x plus 12. Replace x by g of x, so you have 1 divided by g of x plus 12. g of x is just x squared minus 7. طبعا also we have plus 12. Now the definition for the composition, this is the definition for the composition. It's 1 over x squared minus 7x plus 12. But you need to know the restricted value. You don't want the denominator equal 0. So you can write the composition now. If you factor the denominator, you can write it as x minus 3 times x minus 4. So there is two values that will make the denominator equal 0, which is x equal 3 and x equal 4. So these values are restricted. You cannot use them. So the domain of the composition will be all of R, all the real numbers, except x equal 3 and x equal 4. You can write the domain now of f circle G to be x, such that x does not equal 3 and x does not equal 4. And you take all x except x equal 3 and x equal 4. You can write this in interval notation. This is a union of 3 open intervals from minus infinity to 3, union 3 to 4, union 4 to positive infinity. طبعا this union contains any or every real number except the two numbers, which is x equal 3 and x equal 4. Next, we want to evaluate the difference quotient. We will see, you can define the difference quotient algebraically. There's a formula that will give you the difference quotient for any function. It's a matter of, given any function, using the formula will طبعا give you the difference quotient. But we want to know what it means, what the difference quotient represent, and actually evaluate it for some functions. طبعا in this type of problems, to evaluate the difference quotient, there is a lot of algebra. Many of the things we reviewed in chapter R will be used here to simplify the expression. There's two things involved: to make the correct substitution in the formula and to simplify, which will take depending on the function, will take maybe several steps until you simplify the difference quotient. Let's look at the definition of the difference quotient. This is now can be done for any function. The difference quotient represents the average rate of change of a function between the 2 points x and f of x, and the second point is x plus h and f of x plus h. Now you're looking at the first point, the x coordinate is x. If you add h, a positive number, you get a point to the right of x, and that's just x plus h. This is an interval that starts at x and ends at x plus h. And if you look at the picture, this is exactly this interval. The interval that starts at x and ends at x plus h. The length of this interval طبعا is h. Now, to find the average rate of change for this function, we will do exactly what we did before. X will define a point on the graph of the function. The first point is x and f of x. The right-hand point of the interval, which is x plus h, also defines a point on the graph. The coordinate for this point, well, we call it q. The coordinates are x plus h and f of x plus h. This is the y value. So now to evaluate the average rate of change of f of x in this interval, you take f of x plus h, which is the change in y is f of x plus h minus f of x. Now the change in x is exactly h. And if you take x plus h minus x, the result will be h. So this expression here, which we are calling the difference quotient, is exactly the average rate of change for f of x in the interval that starts at x and ends at x plus h. طبعا يعني we will look at an example to evaluate the difference quotient for any function. You need to substitute and use this formula f of x plus h minus f of x divided by h and simplify the expression. يعني your answer must be given in a simplified form. And we will do a problem to explain how to do the calculations. طبعا يعني many of these calculations will review some of the basic يعني rules that we reviewed in chapter R. So here we want to evaluate the difference quotient for the function f of x equal 4x squared minus 5x. طبعا starting with the formula for the difference quotient, we want f of x plus h minus f of x divided by h. So the first step is to evaluate the function f at x equal x plus h. يعني in the definition for f of x, replace x by x plus h. So this whole first bracket is just f of x plus h, يعني the function f evaluated at x plus h. So the function is 4x squared, replace x by x plus h, you get 4 times x plus h squared. Minus 5x, replace x by x plus h, you get minus 5 times x plus h. So this entire bracket here is just f of x plus h, يعني for the definition of f of x, just replace x by x plus h. Now in the formula for the difference quotient, you subtract this, you subtract f of x, so you subtract 4x squared minus 5x. طبعا the denominator is simple, it's just h. So far we only did one step as we substituted, يعني evaluated f at x plus h. This is an important step. يعني given any function to evaluate the difference quotient, this is always the first step, is to evaluate f of x plus h, subtract f of x, and divide by h. Now the remaining steps take some work, some algebra. You need to simplify the expression to get your final answer must be in simplified form. So the first thing to do is x plus, expand this bracket, x plus h squared. You can leave the 4 outside. You get x squared plus 2 times x times h, which is 2xh, plus h squared. Minus, now multiply 5 by the bracket, x plus h, you get minus 5x minus 5h. Minus f of x, you can leave it like it is for now. Next, you want to simplify this expression. You will have 4x, multiply 4 by this bracket, you get 4x squared plus 8xh plus 4h squared minus 5x minus 5h. Now you can open this bracket, you get minus 4x squared plus 5, minus minus will be plus 5x. Now at this stage there will always be some cancellation. You can cancel the 4x squared with the minus 4x squared. You can also cancel minus 5x cancels with plus 5x. So we are left with 8xh plus 4h squared minus 5h divided by h. There is one more thing we can do. H is a common factor for all of the terms in the numerator. So you can divide each term by h. 8xh divided by h is just 8x. 4h squared divided by h is just 4h. Finally, minus 5h divided by h is equal to minus 5. Or you can factor the h from the numerator and then cancel it with the h in the denominator. So here is now your difference quotient. It is equal to 8x plus 4h minus 5.